Assalamu alaikum everyone. Today we are going to conduct lecture number 10 of this online course, and today's topic is stake segment. Remember, in the last lecture we have covered significant portion about stake segment where we developed the basics of stake segment. In this lecture we are going to extend some of the knowledge and try to clarify their usage, the benefits of stake concept, and how to use the stake in different programs and in different subroutines. So let's proceed to the lecture. Okay, in this slide we are listing some facts which we learned in the last lecture. The very first point is data is stored always sequentially in a stake in reverse direction, as we discussed in the last lecture. Then we learned the first word location is never used in this lecture. That means this location, let me highlight it. This location is never used. We learned what are the reasons to not to use this particular location. Then we also learned whatever the last word which was stored on the stake, its logical address is always equal to stake segment colon stake pointer, and this logical address can be converted into physical addressing that we're gonna learn today in this lecture, inshallah. Another point we learned about stake segment, its bottom of stake, and for the bottom of stake pointer's value is always constant, and that is equal to FFE in hexadecimal. And similarly, end of the stake, which is the ending point of the stake, for this particular point stake pointer value is 4 times zeros in hex. And the third and important term which we learned about stake was top of stake, and top of stake is the basically the value up to which stake is filled, and stake pointer is variable in case of the top of stake. And one important fact we learned, whenever stake is empty, then bottom of stake is actually the top of stake, because no data is filled, so basically we are pointing to the bottom of stake, which is also the top of stake at that moment. And another point is end of the stake is equal to top of stake while stake is full, because once stake is full, we can no more fill in further information inside the stake. So the top point of the stake will be equal to the end of stake. So these are the points that we learned in the last lecture. Let's proceed to the next points or next knowledge in this lecture. Okay, in this slide we are going to discuss stack's conceptual benefit, and we are about to make certain assumptions. We are just trying to make things much simpler so that one can understand how this stake is beneficial for the code segment, or for the program, or for the programmer itself. So let's start our conceptual benefits diagram, and we see here three different things. This left thing is basically program. Whatever the program is written here, I've just shown it is a set of instructions, and there are a number of instructions shown. So far in this course we haven't learned any instruction yet, so it is just an start, or you can say for the purpose of showing instructions, nothing more than that. We are not going to learn about actual functions of instructions here, so these are just examples of instructions, not actual instructions. Similarly, these addresses are so simple designed in this particular example. 00 is simple address for this particular instruction, 01 for this particular instruction, 02 for this particular instruction, and so on. So if we can also say that this is kind of line number to these instructions. For example, instruction 1 is a start, and it is written on line 00. Similarly, instruction 2 is basically move, and it is written on 01. So that is the program. We don't know what it does, but we're gonna flow with the sequence of the program. Okay, that this middle thing is basically service routine. Whenever there is a call statement within the main program, this routine will be called. It will serves again, set of instructions will be executed, and then at the end of this service routine, return statement will execute, and that return statement will turn back to the main program. Okay, and so we are not going to take the actual execution of instructions, rather we are going to mimic the effect of its stake on these particular instructions execution. The third and the last thing which is shown in this diagram is a stake, and again we can see here there will be we will be filling the contents of stake, and this is the address of the stake, and we can see that it is pointed by ss colon sp, which is the logical address of last stake used, and here stake is empty, so basically this is also bottom of stake. Let's proceed to the example that we are referring to. Okay, program, this is a program which is written in the code segment, we know, and microprocessor always executes instruction in sequential order, and they will go for example, first of all this start instruction will execute, then this move instruction will execute, then this call instruction, and so on. So this sequence flow will be followed by in code segment. So let's proceed. For example, zero start instruction is basically executed. At the moment of execution, while this start instruction is executing, where our instruction pointer will be pointing this value. Remember, that is a concept we learned in code segment. Instruction pointer always points to the next instruction. That means right now we are working on start instruction, but next instruction is still in the queue, or it is being pointed by this IP. Okay, let's suppose start instruction is done, we are executed with it. Okay, so this start instruction is executed. Now this instruction gonna execute, which is move. Let's suppose now this instruction is under progress of execution. So where the IP will go, IP will switch its position, and it will points to this this address or this next instruction, which is call instruction. Okay, so that is one thing, and let me summarize this thing, that if one instruction is going on, so next instruction to the instruction which is executing will be pointed by IP. Okay, now let's come to this call instruction. Since it is a call instruction, it will call for some service routine which is required for certain purpose by the microprocessor. And so what will happen when this call instruction is going to execute? Okay, let's suppose this move instruction is executed, and now we are working on this call instruction. Okay, where will IP point? This instruction. That is the normal sequence of code segment. Since call instruction is under execution process, so IP will be pointing to this add instruction. Okay, so during the execution of call, microprocessor come to know, okay, this is a call instruction, and we need to switch, or we need to go to a different service routine program which is not written in this particular program or code. For example, let me repeat again. This call instruction, when this call instruction is being executed, microprocessor will come to know, okay, this is main program, and we can't find that service routine in this main program. We have to switch somewhere else. Okay, what will happen? This execution of call instruction will force microprocessor to jump from this address to this address. Okay, this is our service routine, so it will switch to this address. Now what will happen? Since IP was pointing to this address, right, which is add, and that address is 03, but suddenly when call instruction executed, it come to know that this address is no more useful, because the next instruction which is going to execute is this line 51, which is the first instruction of service routine. So what will happen? IP will switch here. That thing will become our IP, because we are going to switch to this service routine now, and now microprocessor going to execute instructions from this part of the code. Okay, that is something. This instruction is executing, so IP will point to this instruction. When this instruction is going to execute, then IP will point to this instruction. When this instruction is going to execute, IP will point to this instruction. Similarly, when this instruction is going to execute, IP will point to this instruction. So far it is quite simple, but once it is going to execute this instruction, what is it? It is saying return. Return instruction will force microprocessor to go back. But where microprocessor will go? They don't have any track of previous program. Remember, when microprocessor switched to this particular service routine, microprocessor's instruction pointer register was holding the address for this register for this instruction. But what happened when we switched to this instruction? IP's content were removed and the new content of 51 was loaded. So IP was pointing to this instruction 1, and now when this instruction is under execution, whatever the next instruction, for example, maybe there is another memory space, we don't know whatever written here, but IP will be pointing to this particular address. Now microprocessor come to know we have to go back to main program, but he can't go. Why? Because he doesn't have any address of previous program. Here we come to the function of stake. So let's proceed the same thing with the usage of stake. Okay, and what is that? Let me proceed the same thing with the usage of stake. Okay, now we are going to repeat same example, but this time we're gonna use this stake. So let's proceed to same example as we did earlier. So program will be executed sequentially. So very first instruction is going to execute will be this instruction, and while this instruction is under execution, this next instruction, which is move and its address is 01, should be pointed by IP. Okay, and once this instruction is done, then this instruction is going to execute, and while this instruction is under execution, the next instruction, which is call here, should be pointed by IP. And while this next instruction, which is call instruction, is going under execution, then the next instruction, which is add and its address is 03, should be pointed by IP. So up to this point, all the steps are similar. What happened next? While this instruction is going to execute, means call instruction, microprocessor will come to know that this is a call, and now he's calling some service routine, so I need to jump to that service routine and leave this main code. So before leaving this main code, what microprocessor do? Microprocessor will save this address, which is the next address, or which is the address of next instruction, which is add. So this 03 should be stored in stake. That is the procedure. So let's proceed using the stake. So what will happen? The value of IP, right, or maybe code segment. Right now we are just considering the things simple. Right now we are just considering only pointer, but remember, in the original case of 8086, the logical address is pointed by two different segments, the code segment and IP. So in the original case, the code segment value will also be stored in the stake, but right now we are taking things much simpler. So only the IP value is going to store in this stake. So 03 will come here, and this stake pointer will switch to this next location, as we learned in the stake it's stake's basics lecture. Okay, so this is now stake value, or this is also kind of top of stake, and this value is stored in stake. Now microprocessor is going to point this instruction, which is our in service routine. Now while this instruction is going to execute, IP will point to this next instruction, and when this instruction is going to execute, IP will switch to this instruction, and when this instruction is going to execute, IP will switch to this instruction, and similarly when this instruction is going to execute, this return statement or return instruction will be pointed by IP. And when this return statement is going to execute, then microprocessor will come to know, okay, this is the point where my service routine is coming to an end, and now I have to go back to the main program. And this time he will be able to go to main program because he has stored he has a track of the previous program in stake, right, which is 03. So what will happen, this 03 will be loaded in this IP. So what will happen, this instruction is going to execute, and this 03 value will come to this IP. Sorry, let me raise it. Let me make the things more easy. So then this 03 value will be loaded to IP. So whatever the IP register, right, there will be some register which is known as IP. It will have a content of 03 back. So that means IP will be coming back to this position. That means the next instruction after this return statement is going to execute will be this add statement. And what will happen here, over here, stake pointer will since this value is no more here, so what will happen, stake pointer will come back to this original position which was earlier set. So that is how one is going to take or retrieve the value from the stake. And now we are going to execute this instruction. While this instruction is going to execute, then this instruction, which is the next instruction, is going to be pointed by IP instruction. So that is the benefit of a stake, and we can see that this is how stake is helping program to track the previous code or to track the previous code segment values. So that is the benefit, or that is the conceptual benefit of stake, and without it these service routine becomes impossible to entertain within the microprocessor. And since these service routine are main important part, there has to be some way to deal with them. So stake is providing that particular way to deal with them or deal with these service routines. I hope I have clearly explained the concept of stakes conceptual benefit. Okay, in this slide we are going to take one more example, that how stake is filled using different subroutines within the main program. So in this diagram we see 4 different portions. This left side portion is program, which is our main program. This second portion of diagram is basically subroutine 1. Since we are using 2 subroutines, so this subroutine is known as SR1 and this subroutine is known as SR2. And in SR2 we see multiple statements including push and pop. So we are going to learn some of their function as well within this program. And the fourth portion of this diagram is a stake, which is empty because stake pointer is pointing towards the very bottom of the stake right now. Furthermore, we have 2 different registers in this diagram, namely AX and BX, and their content is 25 and 4B. You need to keep this thing in your mind. It is still a dummy example. We are not dealing with actual number system involving in 8086. We are just trying to understand the concept of various registers values are going to fill within the stake, or we are various number of subroutines are going to deal within the same program. So it is just a dummy value, so don't consider them actual values, because if you remember, AX and BX are data register and their content should be of 16-bit, but in this picture we see their content is just 25 and 4B hex, which is not of course 16 bits. So that means it is just a dummy value and we are trying to learn only the concept. Okay, let's start our first program. So very first instruction which is going to execute is this start. Let me use this marker. Yeah. Okay, so that is first instruction which is going to execute. Suppose this is under execution, so IP will point to this move instruction or the second instruction. Just to make the things more simple, this arrow will indicate only IP, right? And whenever we are going to deal with stack pointer, we will use different symbol there. So this arrow indicates IP. So right now when start instruction is under under execution, then this move instruction is being pointed with this IP. So once this start instruction is executed, then this move instruction is going to execute. So this next instruction, which is call SR1, it will be pointed by IP. Okay. Once this move instruction is executed, so this call instruction will go under execution. That means this add instruction will be pointed by IP. But when call SR1 is going to execute, microprocessor will come to know, okay, this is now a call statement and I have to switch the main program and I have to go to this service routine which is restarting from 51 address, right? So this address, which is 03, which is the address of next instruction, add, this was pointed by IP, but now since call instruction is executed, so IP will switch to this instruction, which is instruction 1 and written on 51 address. But before switching to this instruction, IP will save this value somewhere, or microprocessor will save this value somewhere, and that is our stake. So that address, which is 03, will come here. Okay, I hope you have understand the point. And now as I told you, we are going to use a double arrow for stake pointer. So stake pointer is no more here and stake pointer is here, so it is pointing the very last value, which is 03, pushed on the stake. So what will happen to IP? IP will switch to this instruction. While this instruction is going to execute, IP is going to point this next instruction. So while this instruction is executed, then microprocessor will going to execute this instruction and this next instruction will be pointed by IP. Now this next instruction is call SR2 and it's again a call instruction, and it will force microprocessor to switch this code of to leave this code, this portion of code, and will switch to this 101. But before switching to this SR2, what will happen? Microprocessor will save this 53 address, which is the instruction of which is the address of the next instruction. In this case, it is instruction 3. So this address of instruction 3, which is 53, is going to store here in the stake. So microprocessor will save this value here. So 53 will be loaded here. So now we stake pointer will switch its value. This is no more here. What will happen now? This IP will switch to this 101. So let me go to this 101. So now this instruction is going to execute, which is push AX, and while this instruction is under execution, IP will switch to the next instruction, which is push BX, or address is 102. So let's come to this push statement, and it is push AX. Push statement is a simple instruction which push any value which is written in the argument. Right here we see AX is the argument of push statement, so the value of AX will be pushed onto the stake. So push is basically used to push any specific value onto the stake. So what will happen now? Whatever the value of AX, and AX value is what? 25. So 25 will go and push up onto the stake. So this will go up here. That means 25 will be stored here, and stake pointer will switch its value. So stake pointer position is no more here. Let me raise these two arrows so that this thing becomes much more clear. Okay, so right now this instruction is going to execute, and this instruction will be pointed by IP. So once push bx is going to execute, what will happen? This content of bx will go onto the stake, which is 4b, and stake pointer will come here. See, stake pointer is switching as we are moving, or as we are pushing more values onto the stake. What will happen at this stage? Instruction 3 is going to execute, and this next instruction is going to be pointed by IP. And of course we don't know what is written here. Maybe it is it's a just a journal name for instruction. So it may happen that the content of these register may be overwritten, or these values are no more here. Maybe these are overwritten, and let's say let me just highlight them so that we know that these values may have changed, may or may not be changed, but we suppose them they are changed now. So let's proceed to the normal instruction code. So now we are going to retrieve the information. Let's see how. Look, this is our next instruction which is going to execute. It says pop bx, and this next instruction is going to be pointed by IP. So what will happen? Now we are going to learn the pop instruction. Pop instruction means to retrieve something from stake. So it says pop bx. So whatever the value, whatever the last value which is stored inside the stake register, kindly pop or retrieve that value and push that value into the bx. So that means what will happen? This content, let me use another color now. This content of stake register which is on the top will go to the bx. I hope you are understanding. So what will happen? It will also reinforce the look. Let me, yeah. So in this manner we are going to retrieve that value back into the bx register, and stake pointer will also switch its position. Let me erase so no values is written now here. What will happen? Stake pointer will be at this location. Now we are going to execute this instruction which is pop ax, and this instruction will be pointed by IP. So what will happen? Pop ax means whatever the last value stored in the stake, it will go inside the where ax. So now ax value will become 25, and this will become empty, and stake pointer will be switching to this value. Let's come back to this execution. So return statement will execute. Return means callback to the main program where you were early working before executing this particular instruction. So what will happen? It will switch back to this address which is the last content of stake. So 53 will be loaded into the IP. That means IP will come back to this position. Let me raise everything because everything has been, this is no more here, and IP will come back to this position. 53 will be loaded, and stake, that 53 is removed from the stake, so stake pointer is on 03 now, and this instruction will be executed. Something will happen, this instruction is going to execute. So IP will be pointing this instruction, and then this return instruction will be executed. So return will force again the last value to be loaded into the IP register. That means what will happen? IP will switch back to this position, right? Let me raise each and everything else. So everything is executed now. 03 is also removed, so stake pointer came back to its original position, and now IP is going to execute from this instruction. So this add instruction is going to execute, IP will point to this position, and that is how we see different values are pushed onto the stake using push command, and different values can be retrieved from the uh, stake using pop command, and call function forces the IP values pushed onto the stake. Similarly, return function or return statement pushes or pop out the values from the stake and push back to them into IP register. So I hope I have explained each and everything in detail. Okay, in this slide we are going to just summarize the two different ways in which we have pushed the data on the stake. So first thing is call instruction. What happened in call instruction? A call instruction is executed to call any user defined subroutine, as we did in two different examples. So in first example we use SR subroutine, and second example we use SR1 and SR2 subroutines. So those two subroutines were called using this call instruction. Furthermore, what happened, a microprocessor automatically pushes the content of CS and IP onto the stake. Remember, in those examples we just pushed the value of IP because we were taking very simple cases. We were not considering CS in our examples, but in actual case CS is part of address, part of a logical address, because these two registers CS and IP actually makes logical address for any instruction. So these two values are pushed into the stake, and remember that means 16 plus 16, 32 bits are pushed whenever call instruction is executed. The second step which we learned was using a subroutine, and at start we can we can use instruction push, which can push any value or any other register's content onto the stake. Remember, in last example we use push AX and push BX. Here we have shown push SI. So in this statement the content of source index will be pushed onto the stake. Next thing we learned, the pop instruction, which is used to retrieve back the information from stake to various registers. Remember, we used the words pop AX and pop BX to get back those values from the stake and reload them into the registers. So push and pop are very important instructions while one is going to use with going to play with stake. Another important instruction we learned, return. Return is always used in the end of the call, in the end of subroutine. So whatever the values was pushed before we called that subroutine, those values will come back into the into their values in their into their original places. For example, in case of call statement, CS and IP were pushed onto the stake. So by the execution of a return instruction, CS and IP will come back to their original places from stake. Okay, thank you so much for listening. That is the end of this lecture. Today we learned various ways in which we can push different values onto the stake. I hope I have explained different things with the right examples. If you have still any confusion, please note them down, and we will try to deal with them in online session. So thank you so much again for listening.